Hey guys, welcome back to another video where I'll continue building the neural network we started. So in a previous tutorial I built the basic network and it's got its weights and biases, it's got everything it needs, and yeah, basically what we've done so far is just so like this, and you can actually see if we run our network we get something like this. We get some randomly generated weights, we have our biases initialized, as well as our neurons, which we can run and get the output. So currently what's happening is our weights and biases are being initialized randomly on every reload, right? I mean, not biases because they're always set to 1, but the weights are being initialized randomly on each one. So if we look at these, then we refresh and look at these, you know, they're just not the same. And this is bad because in the future when we want to learn things, we're going to be updating these weights and biases, and if it's just getting refreshed on each reload, then that's not going to really help. So we need to make sure our weights and biases are being persisted over reloads. So what I actually want to do is add some functions inside of our network class. So over here we want to have something like save. Actually, we can just have something like save network, and this is going to save the network's weights, or let's just say save network weight and bias, just to show that it's saving the network's weight and biases. And what this is going to do is take the weights and biases which we've stored up here, and we're going to save them in this. So once we've done that, we save them, and we also want to have a retrieve network weights and biases. And what this is going to do is it's going to look for the weights and things in local storage. Sorry, this is from another thing, just going to delete all of these. But yeah, it's going to look for the weights and bias data in local storage, and it's actually just going to retrieve them and pass them into our format here. So the way we'll know it's worked is if we go to this, we're putting the same input in every time, and we'd expect the output neurons to be the same every time if the weights are being persisted. So that's going to be our little test scenario, just to make sure that everything is working perfectly. As you can see here, they're not the same because the weights are not being persisted. Okay, so let's get started. Now the first thing I'm going to do is I'm going to work on the save network weight bias, and if we look at our weight and biases storage, they're stored in dictionaries, so this makes them a little tricky to work with. What we're going to want to do is we want to store them in a universal or standardized format so that we can save them here and then retrieve them back here. Now you might be thinking we can just JSON.parse these and then save them, right? But that's not going to work for a few reasons. The biggest being these are saved with the key, and the key is going to be a neuron's ID. But you might notice that the ID of a neuron is also randomly generated. Let's just see if I can find it. So create our network here. Our neuron is going to have an ID which is randomly generated. You might be thinking we can just save the neurons, but then we're going to have to, we can't just save this entire thing as a JSON because these are actually class objects, and if you've ever tried to save a class object as a JSON, you know it just loses all of its functions, which is definitely not what we want. So that isn't an option. So we're going to come up with another solution, which is going to be to extract all of the weights out of this dictionary into a array, and it's just going to have the weights of, let's say, neuron, let's say layer 1 to layer 2, neuron 1 to neuron 2, and then the next one in the layer is going to be the same two layers, but now it's going to be neuron 1 to neuron, actually no, this is going to be neuron 1 of layer 1 to neuron 1 of layer 2, and then this is going to be neuron 1 of layer 1 to neuron 2 of layer 1. So if you can imagine, it's going like this. I would take up the, actually yeah, I'll draw it on like that, just so we can have a visual representation. I'm not going to bother with all of colors, but if you imagine like this, let's just get this. So 1, 2, 1, 2, 3, 1, 2, and yeah, this represents our current network. So two input and output layers, two input and output neurons and 3 neurons in a hidden layer. So what I mean by this format is the first weight that's going to be saved in our array is going to be this weight connecting these 2 neurons, and then the corresponding one which is going to be this weight, and then this was just going to continue on. So the next one is going to be layer 1 to layer 2, neuron 1 to neuron 3, which is going to be this one, and then of course it's going to move on to let me just make this a bit clearer, go on to layer 2, still layer 1 to layer 2, but now it's on neuron 2 to neuron 1. So if you think about it, we're just looping through the 2 groups, just like actually exactly like we're doing here. So yeah, it's going to go here, 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 and then we're going to start again like so, and yeah, now we should have got all the weights. So pretty simple. Let's go back here and let's start implementing this. So since we're going from layer to layer, you should see that we want to get the layers in pairs, like these 2 layers, then these 2 layers. So what I can actually do is just simply copy this code from here, take this out for now, and now we have the current layer which represents this, and the next layer, if this was the pair, this is current, this is next, and then if this was a pair, this is current, this is next, like that. So now what we want to do is we want to loop through the current layer first, for const neuron 1 of current layer. So now we are going to neurons, and we want to loop through the neurons of the next layer as well, like so. And now what you can imagine is on this neuron, it's going to go to all of these, then it's going to go to this one, going to go to all of these, just like that, which is exactly the format which we wanted. Now all we have to do is get the weight, which should just be, if I can find it somewhere, yep, here we go, like this. Let's stop weights, and it's just taking the weight from our weight storage here. Then it's just going to add that weight to the arrays. Let's just create an array called weight flat array. It's going to be an array of numbers, and we'll just add it in like so, and yeah, that should be it. So if we console.log our weight array, and if we go back here, we should see, oh actually I need to save it, like so. We should see we have our thing, and just to confirm, we're assuming that this is going to be the first weight, so between this neuron and this neuron. We can confirm that by finding the ID of the original, which is so the first neuron 0.046, and then in the second layer we have this one, which is 0.045. Then we'll just find that corresponding weight here, so 0.046 and 0.045 is this, and yeah, that is the correct thing. So yeah, now we have the weights in the right order. All I have to do is save this to a path. So I could take in a path variable here, but that's not too important. I might just leave it to make it simple. So all I'm going to do is get the JSON using JSON.stringify and passing this array. This is just a basic array, so it's easy to stringify, and then we're going to set it, and we can just call this network weights. You can just give it that key, and we'll just pass in the JSON like this. Right, so this has saved it to the network. Just like this, if we go here, we actually have our network. So I'm going to cross that out so it doesn't keep saving them now. It's actually reset because I reset it like that. But yeah, so now we have our network weights. The next thing to do is focus on actually retrieving them. So what I'm going to do is I'm going to do this process in reverse. So we get the JSON using local storage dot get item, network weights. Then we just pass this JSON into the weight flat array. Weight flat array equals, let's just specify the type, JSON dot pass JSON. And now we kind of do this process in reverse. So I'm going to copy this code. What we want to do is we have this counter, so let's create a counter here. Let counter, or I'll call it flat counter for to make it easier. This is going to get incremented for 1 in the nested loop, so it's going to basically represent the weight which are currently on in this array. And then what we want to do is we just want to set this, or not even set this, I guess what we could do, yeah, we'll set it. Okay, so what we want to do is we want to do this dot weights JSON dot stringify neuron1.id and neuron2.id. We're going to set that to the weight flat array flat counter, just like that. Right, so that's nice and simple. If we go back to our storage, our thing is the same. And now I'm going to try and use the retrieve network. So retrieve this, we can see it's getting red. If we go to our weights now, so let's look for the first one. I don't actually remember which one it was, that we can check. So we want this first one to be minus 0.196. So if we go to a layer and check what the ID of the first one is, 0.85 and 0.84. So let's look for the one between 0.85 and 0.84, which is here, and that is 0.57. Oh, I actually know what the problem was. I forgot to run this after. Okay, so let's try this again. First ID is going to be 0.25 and 0.82. We're expecting the network weight for that corresponding weight to be minus 0.196. So if we go here, we can try and find the one between 0.25 and 0.82 is here, and yeah, that is minus 1.96. If we look at these other ones as well, I'll just copy this. Actually, I'm not sure if this is going to... okay. And yeah, if we just verify that these are the same weights, in fact, so I can see our 0.108, 0.036 is here. So yeah, these are actually the same weights. The final way to confirm that was, of course, to check if it gives the same output every time. So let's look at the outputs we're getting. We're getting negative 0.22, negative 1.39. Okay, let's refresh, check if we get that. Check same thing. And oh, that seems a bit wrong. Oh, I know what I'm doing wrong again, man. Okay, I'm actually just going to move this over here. We could actually cancel this out, although we probably shouldn't, just because otherwise what's going to happen is there's not going to be a weight. Actually, no, we can't actually just leave this commented out like so. Okay, so now you'll notice there's nothing in the biases, that's expected, but the weights should be what we're looking for. Yep, and if we look at the neurons again, okay, so let's actually check this time. Oh, I'm making so many mistakes, so many silly mistakes. Okay, let's check one more time. I forgot that since the biases were nil, it's not actually going to give you anything. So we have 0.48 and negative 0.06. If we hit the refresh, check again, and yeah, that is exactly the same as it was before. So this is basically all I'm going to do for this part. The only thing left to do really is do the exact same thing, but for the biases, which is actually fairly simple because the biases are only singular neurons rather than being between two neurons. So it's even easier. We can just take these. This is the order I'm going to go in. Let me just write it here. I'm going to go layer 1, neuron 1, oh, layer 1, neuron 1, then I'm going to go layer 2, neuron 2, or neuron 2, layer 1, neuron 2, and then that's going to go on to layer 2, neuron 1, like this. So it's going to go 1, 2, 1, 2, 3, 1, 2, like that. And let's just code this up. So const flat bias array equals number array is nothing, and for const layer of this dot layers, for const neuron of layers layer dot neurons, we'll get the bias we're looking for, which is going to be this dot bias is JSON.stringify neuron.id. We'll save this, or add this, I should say, to the flat bias array, and now we just save this just like we saved the weights. I'll actually move this down here so it's a bit easier. Weights JSON, move that, and biases JSON, biases, and now let's just do the same process in reverse. So we have the weights flat array, let's call this weights JSON, put that there, then we'll do const bias JSON equals local storage.get item network biases, const bias flat array equals JSON.pass bias JSON. I'm literally just doing this process in reverse, so I can just copy and paste that, put that there, reset the flat counter to 0, take that there, increment it per 1, and we're just going to set this dot biases JSON.stringify. Let me just check I'm getting the bias key right. Yep, I am. Okay. JSON.stringify neuron.id is equal to bias flat array flat counter. Right, there we go, and that should be about it for getting retrieving the biases. So I'm just going to test it one last time. What I'm going to do is we could actually initialize each bias to a random value, just so it's a bit easier. So for now, let me just do this. I'm also going to, what's this error? Okay, yeah, makes sense because there isn't anything there. So let me just comment this out here. We're going to save some brand new weights and biases. Go to storage, delete this, save this. Should see that we actually get some brand new weights and biases. Now I'm just going to comment everything out. So here are our network weights, here are our network biases. We haven't actually initialized them. And now I'm going to test the retrieve function, like so. We have our weights now. Let's just check they are the same. So 0.25, same numbers like that. And go here. Let's just look for, let's just copy that. Weights, biases. I'll just copy these, check what we're getting. So the biases, we are getting similar sort of values, yep. And for the weights, let's see what we're getting, 0.084, yep, okay, that's exactly what we're looking for. And of course the final test is just to make sure that we're getting the same values no matter if we reload or not. So let's check if we have same values here. So it starts off with 0.6 and negative 0.15. Refresh, test again, 0.6 and negative 0.15. That's good. And of course I'll show that the value can still change if we change the input values. That's simply just what we're looking for, because if you think of a network as a function, then the value should change if we change the input function. Now if I put it back to what it was originally, we should get the same value as before, 0.67 and negative 0.15. Okay, so that's basically all it was. Thanks for watching, and I'll see you guys in a future tutorial. In this part we added persistence to our network. See you guys in a future tutorial. Bye.